Welcome back to Statistics, and today we're reviewing Module 8, which is all about confidence interval. So the confidence interval is a type of estimate in between an interval of numbers, and the online book shows an example on iTunes where n would be equals 100, sigma standard deviation would be equals to 1, and the sample standard deviation would be that sigma value divided by the square root of n. So in that case, we would simply take 1 divided by the square root of 100, which was our n value, and then that would give us a value of 0.1. So the empirical rule, which we looked at before in other modules, states that 95% of the sample have 2 standard deviations and from the mean mu. So again, that iTunes example from the online OpenStax book describes that 2 standard deviations would be equals to 0.1 for the standard deviation times 2, because we are doing 2 standard deviations, so we would have a value of 0.2 units away from the mean mu. Now, when the mean is x equals to 2 and we have a 95% probability, then we would say that x minus 0.2 is equals to 2 minus 0.2, which is equals to 1.8. So that would be our lower limit. Now, we would also use the formula x plus the 0.2 equals z plus 0.2, which would be 2.2. So the 95% confidence interval would lie between the 1.8 value and the 2.2 value for z. There is a good YouTube on this that describes this in more detail that you might want to check out. It's called How to Calculate Confidence Intervals in Excel by Top Tip Bio, which it's available to you. Now, you might want to review the terminology in this chapter because there are a number of terms that are useful to know more. And the next item that we're going to review is called the EBM, or the error bound of the mean. So this is the margin of error. So the confidence interval estimate will be calculated by the X point estimate, also known as plus or minus the error bound. So there is a good YouTube on this as well. It's called Find Error Bound and Sample Mean by Math is Power, that you might want to check out when you're doing the homework for this module. Now, next we look at finding the confidence interval when the standard deviation sigma is unknown. So the formula for this is we're going to take that t-score and it's going to be equals to x minus mu. And this time we're going to divide it by our standard deviation s divided by the square root of n. So nothing too new. We've already reviewed this, but there is a good YouTube on this as well called the 8.1 Population Standard Deviation Unknown. This is by Professor Ngo, which you might want to check out. And it's a little bit longer YouTube, but it's worthwhile watching for the homework and quiz for this module. We then look at the confidence intervals for the proportion, where P for the proportion is going to be equals to X, which is the number of successes, divided by N, which is the sample size. And then the standard deviation sigma for P is, again, the formula that we looked at in the last module, which is the square root of P times 1 minus p divided by the square root of n. So finally, we get to calculate the sample size for continuous and binary random variables. For continuous variables, our n value is going to be z score squared times sigma standard deviation squared, and then we divide the whole thing by e squared. For the binary, we use the formula n equals z score squared times p times q, and remember p is going to be the estimated value for our successes, and q is going to be the estimated value of our failures, and we divide the whole thing by e squared. And again, there is a good YouTube on this one, and this is called Estimating the Sample Size in Excel by Todd Grande, which you might want to check out. Hopefully this is helpful, and we will be going over examples on our next session. Thank you.